Hello students, very good morning. Welcome to Narayana Live Classes. Today for class 9 students, we are going to discuss assignment number 33 on quadratic equations. Okay? In particular, we are trying to solve few problems based on location of roots. Now let us see the first question. If both roots of the equation x square minus 2ax plus a square is equal to 0 lie in the interval minus 3 comma 4, then sum of the integral parts of a. So we are given a quadratic equation. Then he is saying that the roots are lying in minus 3 comma 4. Then sum of integral parts of a. Let us see what it is. First, consider the given, that is x square minus 2ax plus a square is 0. That is a given quadratic equation. That can be written as x minus a whole square is 0. That implies x is equal to a comma a, that is double root. Okay, so let us take a. What is he saying here? A is in between minus 3 comma 4. A is in between minus 3 comma 4. That is given for us. Given minus 3 is less than, a is less than 4. A is in between minus 3 and 4. Then what is he asking? Sum of the integral parts of a. What do you mean by integral parts of a? Step a. If a is in between minus 3 to 4, what is step a? Step a belongs to set of minus 3, minus 2, minus 1, 0, 1, 2, 3. What is the meaning of it? Suppose a value is in between minus 3 and 4. Let us take one of the values of some minus 2.3. Minus 2.3 is between minus 3 and 4. If it is minus 2.3, what is step of minus 2.3? Minus 3. So it will take minus 3, minus 2, minus 1, 0, 1, 2, 3. Because any value less than 4, step of that is nothing but 3. So these are the step values or integral part values of a. Now sum of the values he is saying, sum of the part, sum of the integral parts of a is equal to sum of all these values. See here, minus 3, minus 2, minus 1, 0, 1, 2, 3. If you sum up, all will cancel with one another. Simply the answer is 0. Okay? Sum of the integral parts of a is nothing but 0. That is the first option. Okay? Now, let us move to the next question. Let x square minus m minus 3 times of x plus m is equal to 0, where m is a real value, be a quadratic equation. Then the value of m for which both the roots are greater than 2. Both the roots are greater than 2. What is the given quadratic for us? X square minus m minus 3 times of x plus m is 0. Here a is equal to 1, which is greater than 0. Here a is x square coefficient, that is 1, which is positive, more than 0. So definitely the parabola is open upwards. The graph of this quadratic is open upwards. He is saying that both roots are greater than 2. So what are the possible cases here? Either this is possible. Here too we have alpha and beta. In this case, alpha and beta distinct. It has distinct roots. Not only that, even this is the possibility. Here in this case, alpha and beta both are same. It is 2. Both the cases are possible cases here. Now out of that, what are the inferences we can get out of this? What are the possible conditions we can take out of it? One is discriminant is either greater than 0 or equal to 0. In this case, discriminant is greater than 0. In this case, discriminant is equal to 0. So we can say discriminant is either greater than or equal to 0. Second condition is if you take corresponding value of 2, that is f of 2. F of 2 if you take that is above the x-axis, that is positive. Even here the same. F of 2 is positive. So f of 2 is more than 0. Okay. Now what about the third condition we can take? The third condition we can take is here the vertex is this point, means at x is minus b by 2a. We have the vertex that we know that minus b by 2a is more than 2. Minus b by 2a is more than 2. So what is the third condition? Minus b by 2a is more than 2. Minus b by 2a is more than 2. These are the three conditions. If you solve these three conditions, these three inequalities, we get a common condition for m. So common value for m. That is the answer for us. Okay. Now let us take first condition, d greater than or equal to 0. D greater than or equal to 0. What is discriminant here? m minus 3 whole square b square minus 4ac 4m greater than or equal to 0. That implies here we can say m square plus 9 minus 6m minus 4m greater than or equal to 0. That is otherwise m square minus 10m plus 9 greater than or equal to 0. That is otherwise m minus 1 times of m minus 9 greater than or equal to 0. M minus 1 times of m minus 9 greater than or equal to 0. As it is greater than or equal to 0, we have m is either less than 1 or m is more than or equal to 9. M is either less than or equal to 1 or m is more than or equal to 9. So this is condition number 1. That is the condition number 1. Second condition is f of 2 more than 0. F of 2 more than 0. Let us take. Second condition is f of 2 is more than 0. That implies wherever you have x, in place of x we have to write 2. So we have 2 square minus m minus 3 times of 2 plus m greater than 0. So if you consider, take the condition, we have x square minus m minus 3 times of x plus m. So in place of x what I have to write? 2. 2 square minus m minus 3 times of 2 plus m greater than 0. So if you take that, it is going to be 4 minus 2m plus 2 3s are 6 plus m greater than 0. That is otherwise minus 2m plus 7, that is minus m plus 10 greater than 0. It implies m minus 10 less than 0. That is otherwise m less than 10. That is the second condition. M less than 10 is the second condition. What is the third condition we have? Minus b by 2a is more than 2. What is minus b by 2a? Minus b means m minus 3 by 2 times of a, that is 1, is more than 2. It implies m minus 3 is more than 4, that is m greater than 7. M greater than 7, this is the third condition. From 1 to 3, what is the common condition we can take? From 1 to 1 3, here m is more than 7, in this case m is less than 10, and if you take this first condition, m less than or equal to 1 or m more than or equal to 9. Anyway, third condition is m more than 7, so this is not considered. M more than or equal to 9 can be considered, and m, so by using that you can say m belongs to closed 9 comma 10 open, because here m is less than 10. According to this, m can be any value more than 7. According to first condition, m can be any value more than or equal to 9. But here we have restriction for m. M is less than 10. So m can be taken up to 10, that is open. So closed 9 comma 10, that is m. Therefore, out of the given options, which is the right answer? If you take, that is second option is the right answer. Closed 9 to open 10. Okay, that is the reason why for second question, second option is the right answer. Now let us see the next question. If a belongs to R and the roots of x square minus 2x minus a square plus 1 is equal to 0 lies between the roots of x square minus 2 times of a plus 1 times of x plus a into a minus 1 is equal to 0, then a belongs to. It's a very good question. Let us try to solve it. First, let us take the given equations. Let us take f of x as x square minus 2x minus a square plus 1 is equal to 0. Okay, now g of x is the second condition. Let us take x square minus 2 times of a plus 1 times of x plus a into a minus 1 is equal to 0. What is the condition he is saying? What is he trying to say? Here, the roots of this lies between the roots of this. The roots of that lies between roots of this. Okay. Now, let us try to simplify f of x. F of x we can write as x minus 1 whole square minus a square is 0. That implies x minus 1 whole square is a square. That is otherwise x minus 1 is plus or minus a. Therefore, x is equal to 1 plus a comma 1 minus a. Okay, the roots of f of x we got as 1 plus a and 1 minus a. Okay, so these roots are, means these are 1 plus a and 1 minus a are roots of this. They are lying between the roots of this equation. So let us take the diagram for that. Why I am taking this diagram? Because here for the first condition f of x, we have two roots, that is 1 minus a and 1 plus a. Both are distinct, so definitely this is how the curve is. X square coefficients in both the cases 1, that is more than 0, so it is open upwards. Here these roots are lying between these roots, so definitely here also we have to have distinct roots. So this is the diagram. In this is f of x and this is g of x for us. F of x and g of x for us. Now, so these are the roots of second equation g of x. These are the roots of first equation f of x. Already we got the roots as 1 minus a and 1 plus a. Okay. Now, what is the conclusion we can make? If you consider corresponding value of 1 minus a, that is g of 1 minus a is less than 0. G of 1 plus a is also less than 0. We can take that condition. The first thing is g of 1 minus a is less than 0. Second condition is g of 1 plus a less than 0. Okay. Now, both the discriminants are what you can say greater than 0. Discriminant of this is greater than 0. Discriminant of this also greater than 0. But these two conditions are sufficient to write the answer. Now, if you look at g of 1 minus a, that implies what is g of 1 minus a? What is g of x for us? G of x is x square. That's what I have taken. X square minus 2 times of a plus 1 times of x plus a of a minus 1 is 0. What is that? X square minus 2 of a plus 1 times of x. X square minus 2 of a plus 1 times of x plus x square minus 2 of a plus 1 times of x plus a of a minus 1 is 0 plus a of a minus 1 is equal to 0, but here it is less than. Based on this condition, if you simplify that, we are going to have 1 plus a square minus 2a minus 2 into, or we can say, okay, minus 2 times of this is 1 minus a square plus a square minus a less than 0. If you simplify further, we are going to have the entire answer as this is a square minus 2a plus 1 minus 2 plus 2a square plus a square minus a less than 0. Further, if I simplify a square, 2a square, 3a square plus a square, that is 4a square minus 2a minus a, that is minus 3a, 1 minus 2, that is nothing but minus 1 is less than 0. If you factorize this, this is going to be 4a square minus 4a plus a minus 1 less than 0. That is otherwise, if you take 4a common, you have a minus 1 plus 1 of a minus 1 less than 0. That is otherwise a minus 1 times of 4a plus 1 less than 0. It implies a belongs to, here less than equal to we have, so it is nothing but minus 1 by 4 to 1. This is condition number 1. So what is the condition we have? A belongs to minus 1 by 4 to 1. Okay. Similarly, you have to take g of 1 plus a less than 0. First condition, what you got? G of, that is a belongs to minus 1 by 4 comma 1. Now, let us try to take the next condition, g of 1 plus a less than 0. For that, g of 1 plus a less than 0. The first condition, what you got? We have got that is a belongs to minus 1 by 4 to 1. Let us keep it aside. Now let us take g of 1 plus a less than 0. G of 1 plus a, that is 1 plus a whole square minus 2 of 1 plus a into 1 plus a plus a of, okay, x square, that is a plus 1 plus a whole square minus 2 of a plus 1 into 1 plus a plus a of a minus 1. A of a minus 1, that is less than. That implies we have 1 plus a square plus 2a minus 2 times of 1 plus a square plus 2a plus a square minus a less than 0. Let us simplify that. Here it is a square plus 2a plus 1 minus 2a square minus 4a minus 2 plus a square minus a less than 0. That implies a square minus 2a square cancels. So we have 2a minus 4a minus a, that is nothing but minus 3a plus, that is minus 1. Okay, because 1 minus 2 minus 1 is less than 0. That implies 3a plus 1 is more than 0. That implies a belongs to, Okay, 3a plus 1 is more than 0 means 3a is more than minus 1. A belongs to minus 1 by 3 to infinity. This is the second condition. If you consider both the conditions, first condition is a belongs to minus 1 by 4 to 1. Second condition is a belongs to minus 1 by 3 to infinity. If you plot them on the number line, so here minus 1 by 3 is here, minus 1 by 4 here, here we have 1. So according to first, the value lies between these two. So this is how we have the line, values of a. Second one, the values of a are like this. So common reason is nothing but this. So minus 1 by 4 to 1, that is the value of a. Therefore, from 1 and 2, we can conclude that a belongs to minus 1 by 4 to 1. Okay? So out of the given options, minus 1 by 4 to 1 is nothing but the second option. So that is the right answer for this question. Okay? That is the end of today's assignment. Thank you. Have a good day.